Did I already set that up? All points that are the same distance from a center. And what do we call that distance? Distance from the center to the sphere is the radius. The distance is the radius. So if we have, the way we usually draw a sphere is if we start with, I need to do this. Okay. All right, so we start with a circle, and then you can make the kind of around like so. And then this distance from here to here would be the radius. And that's really all we have to worry about with spheres. It's a little complicated to show where our formulas come from. Our other shapes, we broke them into smaller pieces and added up the areas of the smaller pieces, or we talked about how we come up with the volume, the idea of the volume. Sphere is a little more difficult, so we're just going to talk about the formulas. But one thing really quickly before we talk about the formulas, what is a hemisphere? Half a sphere. So if there's a problem that says find the surface area of a hemispherical dome, they just mean half a sphere. All right, so let's talk about our formulas. Formulas are really easy. The only thing that we have to keep track of with a sphere is the radius. That's all we have to worry about. That's one thing that makes spheres nice. All right, so volume. Our volume is V equals 4/3 pi r cubed, units cubed. And r is just our radius. Four-thirds, I can do this 4/3 a couple of different ways. Usually I just multiply by 4, calculate this out, multiply by 4, and then divide by 3. And our surface area another nice easy formula. Surface area is 4 pi r squared. Again, all we have to keep track of is the radius. So that makes them kind of nice. Yes? The spheres, these two came from the ancient Greek. I'm not sure exactly the person, but they figured it out back in Greece. Yeah, it's kind of tricky to figure it out. All right, let's look at a couple of examples. Let's say our sphere with a diameter of 24 millimeters. We want to find the volume. volume in terms of pi. Well, what do we need to plug into our formula? The radius. For a sphere, the radius is the key. That's the first thing we have to figure out with a sphere when we're talking about surface area and volume. We have to figure out the radius. So what is the radius? Radius is 12, half the diameter. Then I plug that into my calculator. So the volume is 4/3 pi times 12 cubed. And let me show on I have the calculator up here to show you how to do a cube on your calculator. I'm going to do 12, and then this little up arrow, and then 3. So 12 cubed is 1,728. On on the older calculators, you might have a button that looks like it might say y to the x. So you do 12 y to the x 3. Same kind of thing. All right, so this is 4/3 pi times 1728. And what I would do is I'm just going to multiply 1728 by pi, multiply by 4, and then divide by 3. So I'm going to do the answer times, let's see, where's my pi button? Do I have a pi button? Times pi. And then I'm going to multiply by 4, and then divide by 3. And I get, oops, I said in terms of pi, didn't I? Yeah, this would be my decimal answer. So in terms of pi, I'm just going to do the 1728 times 4, and then divide that by 3. So I get 2,304. So 1728 times 4 divided by 3 is 2,304 pi cubic millimeters. Nice, easy calculation. All right, questions there? Okay, let's get another one. Let's say we have a baseball. It's a diameter of 2.9 inches. How much leather do we need to cover it? What is this question asking us to find? Surface area. How much leather to cover it is the surface area? We want to find the surface area. And what quantity do we need to plug into our formula? The radius. How do we find the radius? The diameter divided by 2. 2.9 divided by 2. And when I do that, I get 1.45 inches. Plug that into my formula. The surface area equals 4 pi times 1.45 squared. And this doesn't say in terms of pi, so I'm just going to multiply this all out. And I get about 26.42 square inches. So it takes about 26 square inches of leather to cover this baseball. Yes? Surface area is how much area, what does it take to cover it, and for the volume it's how much is inside. All right, let's look at one that's a little trickier. So the sphere has a volume of 1,000 cubic meters. What is the surface area? So what's our key? What's the key to a sphere? What do we need to figure out for our formula? The radius. We have to find the radius. So that's our first step. We have to find the radius. How can we find the radius here? So I think you're on the right track. Okay, we have a formula for the volume, right? We know that the volume is 4/3 pi r cubed. But we also know the volume is 1,000 cubic meters. So I'm going to plug this into the formula and solve for the radius. 1,000 equals 4/3 pi r cubed. And now we want to solve for the radius. Well, we need to get r by itself. So what are we going to do to get all this stuff away from r? And so, what do we? Let's just think of this fraction. How do we undo this 4/3? Let's just do it a step at a time. How do we get rid of this 3 in the denominator? Multiply by 3. So I'm going to multiply both sides by 3. Those cancel. So I get 3,000 equals 4 pi r cubed. Now how do I get this 4 out of here? Divide by 4. And isn't pi just a number? Can't we divide by 4 times pi? 4 times pi is just some number. A little more than 12, right? Those cancel. 3,000 divided by 4 pi. If I plug that in my calculator, so if I go here, what I would do is 3,000 divided by, and I'm going to do in parentheses, 4 times pi. I get 238.73. So r cubed equals 238.73. How do I undo this cube? And we square root to undo a square, so to undo a cube root, we cube root it. And a cube root looks like this. So let me show you how to do a cube root on your calculator. Most calculators are going to look just like this, more or less. If you have something different, an older calculator, I can show you how to do the cube root on your older calculator. The root button is here, this shifted button. So you should have one that looks like this. And I want the cubed root, so I'm going to do 3, and then hit that button. That tells me I'm doing the third root. And then I put 238.73. So I get 6.2. So I do the cube root of 238.73. So I get the radius equals 6.2. And then I'm going to plug that into the surface area formula. So the surface area equals 4 pi times 6.2 squared. And I plug that into my calculator just like that. And I get 483.1 square meters. So there's my answer. So the key to a sphere is you have to find the radius. That's what we need for our formula. Find the radius. If you have a different kind of calculator or an older type calculator, I can show you how to do the cube roots. Some of them I like. That one I know is different. So slightly different. And does anybody have the TI-84? So if yours is different, I can show you during work time how to do it. Yeah, so you do the 3 and then that button and then All right. I don't think we need to go all the way through this example. I just want to talk about it really quickly. Let's say we have a ball with circumference of 25 inches. Find the surface area. So what's our key here? What do we have to find? Find the radius. Once we have the radius, we can plug it into our function. How are we going to find the radius here? Right, so what Carolyn said was we're going to divide 25 by 2 pi. And the reason we do that is because we know that the circumference equals 2 pi r. So 25 equals 2 pi r. We need to find the radius. Divide by 2 pi. Those cancel. So the radius equals 25 divided by 2 pi. Plug that in my calculator, and I get the radius equals about 3.98 inches. And then I can plug that into my formula. So the surface area would be 4 pi times 3.98 squared, which is about, what's 199, not 119? Squared. So the key for spheres, you have to find the radius. And don't forget the other things that we've learned in the past about circles and radii. All right, questions? Okay. Oops, not example, homework. All right, there you go.